This is the activity example 1 ultrasonic sensor. This setup involves connecting an HC-SR04 ultrasonic sensor to an Arduino Uno for distance measurement. The red wire connects the sensor's VCC pin to the Arduino's pipe V pin, supplying power to the sensor. The black wire links the sensor's ground to the Arduino's ground pin, ensuring the circuit is grounded. The green wire connects the sensor's echoPin to digital pin 11 on the Arduino, responsible for receiving the reflected sound waves. The blue wire connects the sensor's trigPin to digital pin 10, which triggers the sensor to send out ultrasonic pulses. This configuration is commonly used for detecting distances by timing how long it takes for the pulse to bounce back from an object, making it ideal for robotics, obstacle detection, and other distance sensing applications.
So in example 1, we define the trigPin to send out sound pulses and the echoPin to receive the reflected sound. We also declare two variables, the duration to store the time it takes for the sound to travel, and distance to calculate how far the object is. In the setup function, we configure the trigPin as the output and the echoPin as the input. This lets the Arduino send sound pulses and receive the echo. We also start serial communication, which allows us to print the measured distance to the serial monitor. In the loop, we first clear the trigPin to ensure no stray signals are sent. Then we send the pulse by setting the trigPin high for 10 microseconds. Next, the sensor listens for the pulse to return, and the duration variable records the time it takes. We then calculate the distance using a formula to account for the round trip of the sound wave. And finally, we print the distance to the serial monitor so we can see how far away the object is.
We know that it is possible to directly connect our Arduino to the ultrasonic sensor. In this case, we have demonstrated that another method is possible by using the breadboard as where we use as a bridge. The 5 volts was connected to the positive charge of the breadboard to provide necessary power for the sensor to operate, and then the ground is connected to the negative charge in order to compute the electrical path, allowing current to flow from the positive side through the components and back to the ground. We then connected the trigger pin to pin 10 so that the Arduino can send a signal to the sensor. Pin 10 is configured in the code as an output pin to send a pulse to the trigger pin of the sensor, initiating the measurement process afterwards. We connected the echo pin to the 9 pin on the Arduino to retrieve a signal that the sensor sends back after detecting an object. The Arduino measures the time it takes for the signal to return, which is used to calculate the distance.
The trig pin is set to 9 and the echo pin is set to 10, where the sensor trig and echo pin are connected to the Arduino. In the setup function, we tell the Arduino that the trig pin will send a signal output and the echo pin will receive the input. We also start by the serial monitor with the Serial.begin 9600 so that we can see the distance output. In the loop function, we start by sending short pulse from the trig pin to measure the distance. The function pulseIn listen to the echo pin. We then calculate the distance by using the value of duration and multiplying it, then divide it by 2. Then the calculated distance is displayed on the serial monitor and the process repeat every 100 milliseconds.
In example 3, the 3 LED lights serve as visual indicator of distance. Red LED object is very close, yellow LED object is at medium distance, green LED object is far away.
So for the ultrasonic sensor, the VCC is connected to 5 volts, the ground is connected to the ground, the trigger is connected to the pin 7 on the Arduino, and echo is connected to the pin 6 on the Arduino. So for the buzzer, it is directly connected to the breadboard.
Ultrasonic sensor, LED, and buzzer to Arduino Uno. Coding part. So in the first part, we are going to code on how we are going to get the value of the ultrasonic sensor, which is the distance. So in ultrasonic sensor, we use that to get the distance of something, and the ultrasonic sensor from point A to point B. So for us to use this, or for us to get the value of the ultrasonic sensor, we are going to create a method with a method named read ultrasonic distance with a parameter of trigPin and echoPin. And written in our code, we use pin number 7 for trigPin and pin 6 for echoPin. Now, in our method, we are first going to turn off our trigPin to clear the value, or for us to start, since trigPin is the start of getting our value. After we turn it off, we are going to turn it on for 10 microseconds, then turn it off, then we are going to get the value in the echoPin. And that echoPin, it has the pulse value, which is we are going to return it to get the distance. So the pulse value of the echoPin is going to be multiplied by 0.01 723, and that is the distance between that certain object and the ultrasonic sensor. And later on in the code, that distance is going to be used for us to power on or light on our LEDs and work on the buzzer.
If distance is greater than 200, all pins are low. Else if distance is less than 200, and distance is greater than 150, pin 8 is high, or green light is high. Else if distance is less than 150 and distance is greater than 150, pin 8 is high, or green light is high, and pin 11 or yellow light is high. Else, all pins are high.
Okay. Taas, taas, taas. Taas. Wag, okay. Baba. Wait. Taas, taas. Okay, baba na. Dahan-dahan, dahan-dahan. Okay na yan.